Muy buenos días con todos. Para mí es un gusto tenerlos acá en nuestra experiencia muy grata, el tenerlos desde Francia, esta conexión para nuestros estudiantes y también hemos invitado a algunas personas externas. También invité a personas de la autoridad reguladora que te conté que trabajan en la parte de radiación. Sí, esperemos que se puedan conectar para que estén con nosotros. Sí, también hay investigadores de, de la universidad.
Ok. Il est très heureux de la possibilité de réaliser ce séminaire, très en gratitude de pouvoir nous accueillir, d'accueillir ce groupe français dans ce séminaire. Et il y aura la participation à la fois d'étudiants, de professeurs de l'université, mais aussi des agents de l'autorité de régulation nationale des radiations ionisantes. Il n'est pas sûr qu'il puisse se connecter, mais bon, en tout cas, il les a invités.
Para el día de hoy tenemos algunos expositores, ¿sí? Desde Francia. La persona que nos está apoyando es Silvia Becerra, la persona de contacto que hemos tenido en Francia.
Et bon, il dit que je suis la personne de contact en France et voilà.
Sí. Hay estudiantes de la materia de contaminación radiactiva de la carrera de Ingeniería Ambiental de la Universidad de las Américas.
Il y a des étudiants de la carrière d'ingénierie environnementale, je pense que c'est comme ça qu'on dit en France aussi, de l'université.
Y también público externo.
Et aussi des publics externes à l'université.
Entonces, Silvia, te doy la palabra para que nos ayudes a moderar el evento del día de hoy.
Sí. Bueno, pues buenos días a todos. Estoy encantada de poder abrir este seminario con Yasser. El trabajo que vamos a presentar ahora no son tanto resultados, son mayoritariamente, el objetivo es presentar una metodología de trabajo y una experiencia que se está haciendo en Francia alrededor de una zona taller para estudiar diversos procesos sobre efectos de bajas dosis de radioactividad. Entonces vamos a tener primero la presentación de Patrick, luego creo que va la de Clarisse o Gilles, la de Clarisse, que estará en español, la de Gilles en inglés, la de Sylvie y luego la mía al final. Cada uno en su propia competencia, vamos a decir. Yo, por ejemplo, soy socióloga y yo recién vengo de llegar en la zona taller, pero tengo una experiencia de trabajo en Ecuador que intentaré compartir con ustedes luego. Bueno, pues podemos ya, si quieren, empezar, ¿no?
Sí, para nosotros el tema de la radiación natural es muy importante, sí, ya que se ha hecho muy poca investigación aquí en Ecuador, sí, principalmente por parte de algunas universidades y por parte de la autoridad reguladora. Entonces, estamos gustosos de tenerlos el día de hoy para aprender muchas de las cosas y experiencias que han realizado de su grupo de investigación.
Le thème des radiations naturelles est très important pour eux, d'autant plus qu'il y a eu très peu de travaux en Équateur, que ce soit au niveau de la recherche ou des autorités de régulation.
Sí, podemos empezar.
D'accord, on peut commencer. Patrick, on va te laisser la parole. ¿Podemos ponernos de acuerdo que si acaso hay alguna pregunta que se haga en el momento o más bien después?
Yo pienso que al final de cada exposición la pueden,
Mejor.
okay, ponen en el chat y las podemos...
Ok, d'accord. Alors, ils préfèrent qu'on parle et les questions et discussions viendront à la fin. ou par le chat ou par la prise de parole directe.
Ok. Alors, Sylvia, c'est bon, vous voyez comme il faut? Ouais. Can you see? Yeah.
Yes.
C'est pas un diaporama, Patrick.
Ah, je ne suis pas en diaporama. Sorry.
Ben, por favor, Yasser, cuando pongo la pantalla, cuando comparte la pantalla, me dice si se ve correctamente.
I try again. No, it doesn't work, no.
Tu n'arrives pas à partager ton écran? Si tu enregistres ton document en PDF.
Ouais, c'est ce que je vais faire, sorry.
Ilia, tu as donné les droits à tout le monde de partager? Il l'a peut-être pas, hein?
Oui, si.
Si, Yasser qui l'a fait, ouais. Tu le vois quand tu cliques sur participant, il y a écrit co-animateur.
Ok.
Mientras voy a decir que tenemos uno de nuestros estudiantes que está también conectado, Théo Bourgoin, que viene recién de llegar en el programa de la zona taller. Si le deseamos la bienvenida también.
Ya está la pantalla de Patrick.
Okay.
So
Go
it
on.
works now, yeah. Hope so. Yeah, you can see everything. Okay. Hello. Good morning. My name is Patrick Charton. I'm a research engineer at the CNRS, and I'm very happy to present you what we're doing in France in the context of natural occurring radioactivity. I would like to present you the context of our interdisciplinary scientific collaboration in which we work all together with Clarisse, Sylvia, Sylvie, Gilles, and means the Zone Atelier Territoire Uranifère, ZATU. We are all of us involved in ZATU's research programs. Gilles, David Biron was not there, and me, we are in charge of the coordination of the ZATU. First of all, I'd like to introduce what is the concept of Zone Atelier in France. Zone Atelier is an interdisciplinary consortium of researchers working on different territory. So by using a socio-ecosystemic approach, we carry out fundamental research and long-term observations on the interaction between an environment and people who occupied and exploit it. At the moment in France, as you can see here, there are 14 zone ateliers which are labeled. 12 of them are in the metropolitan territory, and there are 2 others, one in Africa and another one in Antarctica. The Zone Atelier networks belongs to the European long-term ecosystem research and to the international long-term socio-ecosystems research. The 2 key words you have to keep in mind about Zone Atelier are sociology and ecosystems. As you can see in our conceptual scheme of the Zone Atelier, you have 2 templates, one social template and one biophysical template. And the middle, we have a territorial landscape where all of this are interacting all together. And what we want to assess and to look at the way this landscape is changing by the different action of human or biophysical action. Among the 14 zone ateliers, there is the Zone Atelier Territoire Uranifère, which was labeled in 2015 and renewed last year. There are 24 members. The laboratories belongs to university, to the French National Center for Scientific Research in different disciplines. Also, we have the Office for Geological and Mining Research, the Institute for Agriculture and Environment, and the Commissariat for the Atomic Energy, and the French Institute for Radioprotection and Nuclear Safety. So we focus here on the long-term effect of low doses of natural occurring radioactivity or enhanced natural occurring radioactivity on socio-ecosystems. There are 72 persons working on this different project that makes a full-time equivalent of 22. We have 12 PhD candidates and postdoc. As I mentioned before, what we are focusing on is the low dose effect. Here you have the schemes that present the linear threshold model. We know what's going on with the high radiation doses, but it's still a big question about what's going on with the low dose radiation. And here we are working on the four different categories of ecosystem service. First of all, the supporting service, I mean the habitat or the soil formation and so on. The provisioning services, what kind of food we can have from this environment, raw material like wood and so on. The regulating services like, for instance, climate regulation by carbon sequestration, for instance, and the cultural services offered by this environment. So we focus on this here is our frame of the ZATU. Our research program are focused on four main themes. The first one deals with the adaptation and evolution of life in the presence of enhanced natural radioactivity. The second deals with the problem of the transport and the transfers of the radionuclide. And the third one is dealing with the perception of the associated risk to this radioactivity. These three themes will have to be integrated in a data into a socio-ecosystemic dynamic model in order to help decision makers and different stakeholders to find out what is the best territorial management, depending on the situation, of course. And the fourth theme deals with instrumentation and data management. In our site, we have several different smart sensors. Here on the left, you can see a sensor for water analysis. These sensors are connected, and then the data are sent right away to the laboratory, so we can have all the data transferred right away from the site, and we can have better analysis about what's going on. What about our site and observatory? As I mentioned before, we are looking at the low intensity exposure of radioactivity, but there are two objects we are interested. The first one deals with the chronic, long-term chronic low intensity exposure. It's on the right, I mean, it's the radioactive springs that you can find in Auvergne. Here you have an important gradient of physical, chemical, and radioactive condition in the different springs. A spring is also characterized by very stable condition over the time. And there are many uses from human, like drinking, swimming, and so on. Here we focus on the inventory of radionuclide you can find in the spring, and the past radionuclides also by measurement carried on travertine, for instance. We will look at the effect of exposure and also the adaptive evolving capabilities, and also the risk related to human action when people are drinking this kind of water. The second kind of site we are interested is the former uranium mine, and the one we've chosen is the mine of Rofin. Here we have a different kind of chronicle exposure. I mean that this mine was exploited from 1946 until 1957. Here we are in the context of a change, of a radical change of the biodiversity exposure to radioactivity due to human action. Our site is quite interesting for us because it's an environmentally classified facility, since there are 32,000 tons of residue of our treatment. And one thing that is unique in France, is that there has been the trees and the biodiversity has developed by itself on the place. We are not in the same conditions than in other former uranium mine, which are maintained like a golf course. Here we have trees and so on. The watershed is also quite small, so it's easy to model, to have a model for the hydrogeological conditions. And here we will mainly look at all the aspects I mentioned for springs, but also the long-term management and evolution. Since you have a repository which will be dangerous for several hundred years, we can wonder what will go on within 200, 300, or 400 years. And all of this kind of sites, there are of course human and social sciences that are interested in the trajectory of the risk. I mean, at the beginning of the 20th century, for example, radioactivity was very fashion and very accepted by everyone. And nowadays it's more difficult. Now, I just would like to give you an idea of the dose we can have in our site, either for people or for the environment, just to give you an idea on what we are working on. For the dose for human, we are using the robust method that you already know. I mean, we use first of all the activity content and the external exposure, which are either measured or modeled. We use, of course, the dose coefficient for each radionuclide and the age in the context of age groups, ingestion or inhalation, and so on. The reference population groups, scenarios, and also a lot of statistical data like local food consumption, dust concentration in the air, respiratory flow, and so on, and the daily water consumption. We usually use data that are mainly in a context of very conservative approach. Here on this slide, in the case of our springs, the springs that we study are used for drinking, for bathing, for mud bath. There are also public work next to the springs. So the exposition is correlated to ingestion of water and sediment, to inhalation of dust, skin contact, also with water and sediment. Just to give you an idea, the results of the sediment analysis by gamma spectrometry. And here you can see that in the sediment of our springs, we reach the same concentration of radionuclide as the one we can find in uranium ore treatment residue. So it means that it's already very high context, and the springs are open to everyone. Everyone can go and take water and do whatever he wants. Here are the results for the dose expected to the spring. As you can see, I mentioned the 1 millisievert, which is conventionally considered as a threshold in the context of dose assessment. You can see that some springs can induce only for internal exposure a level of 8 millisievert, depending of the age group. And so we can say that our springs might be dangerous in this context. Some idea of the limits and some comments about this assessment of doses for public. The tools are really perfect to confirm when there is no risk. That's the first things. In the context of not-norm, we have also the situation is more complex than for NPP for instance. We have also troubles with dynamic radon measurement for realistic doses assessment. We have trouble also with the background characterization. What can be considered as a reference level of radioactivity. And we have also to question ourselves about the representativeness and the reliability of the scenario we use the samples and the data. One other thing and one other aspect is also that people, when they drink this water from the spring, they expect medical benefit from it. And what is the priority for people? I mean, is the medical benefit more important than the risk, radiological risk? And the last question also, we wonder a lot in the global for all of our sites, is about the land use by the future generation. We talk about the repository of ore residue. What will do people within 200, 300, or 400 years? In the context of environment, I hope that I'm okay with the time. In the context of environment, until 2013, there was no specific things for the environment, since we used to consider that protecting human beings means involve environment protection. That's a philosophy that has been considered for many years. Indeed, it's not true. Humans are not the most radiosensitive organism on the Earth. So since 2013, we are working with a new European directive that tells us that the environment must be protected, not for itself, but as a place for human life. So this new philosophy shows us that we were lacking of tools and instruments to assess the environmental dose. And there has been a large program in Europe that was proceeded by different organisms, among which the IRSN, the Institute for Radio Protection and Nuclear Safety from France, who is a member of ZATU, and they developed ERICA tool to assess the impact on an environment of radioactivity. There is a big first simplification that is done. It is to decide to study reference organisms that are considered as the micro-indicators of the ecosystem health. So you have the idea of the reference organism for terrestrial, marine, and freshwater. Here it is just a very complex scheme, but it's just to explain that ERICA consists in 3 steps assessment. Each step, tier 1, tier 2, tier 3. Each step is less conservative and more site specific. If you can have an answer very quick by just checking whether the activity is at a level which is very far away from any effect, you can decide that it's okay, it will not make trouble. So you have different steps to assess the impact on the environment. The tier 1 assessment is designed to be very simple and conservative. It requires a minimum of input data, and then you can decide whether there is a risk situation or not. If there is a risk situation, you have to go to tier 2, and again, if you have risk situation at the end of tier 2 assessment, you have to carry on tier 3 assessment. What is the global approach of ERICA tool? The only thing you have to know is the activity concentration in the reference media, I mean the sediment in the water and the soil. And thanks to the different coefficients, you can define the activity in the reference organism. Then you can calculate the internal dose rate. And when adding internal external dose, you have the total absorbed dose. This dose is compared to a database, Federica, which gives all the information the phone on the floor we can find in Europe, and then you can decide whether there is a trouble or not. But one or two other information about this tool is that there are many simplification. I mean, for instance, for the calculation of the external dose, we consider that any organism is the same. I mean, it's an ellipsoid, even if it's a rat or a fish. You don't consider the ears, the legs, and the tail, and so on. Every animal is considered like an ellipsoid, so it's a first simplification. And for the determination of internal dose, you can see that the interaction between radionuclide or biodiversity is very complex. So there is a simplification that is made to consider what is the uptake by the grass from the soil of radionuclide, and then what is going to the animal via ingestion. So it's only using, we are only using 2 or 3 factors to represent this this kind of very complex model of the interaction. So for our former mine of Rofan, I mentioned before, we have a sample of sediment from downstream of the site. We have something like 1,000 becquerel per kilogram of uranium-238 and 50 becquerel of uranium-238. And the first screening we can make with TR assessment, number 1, you see that there is a risk. If the ratio is higher than 1, you are sure that you have a risk. So you have to go on with your assessment of the dose your reference organism might take. And here you can see the TR assessment results. I'm sorry, not in PowerPoint. You can see that here in our condition, we can find out that there is a risk for the different organism reference. So it means that it's very complex to have an idea of the effect of radioactivity, because with simple tools we are usually using very often, you can decide whether there is you show that there might be a risk to the different organisms. So the method of ERICA is quite well designed for most of the situation, but for Nortenum it's not very adapted, because the database are quite empirical and complete. There is also important dispersion of the values that are used to make the assessment. I mean, for same kind of spaces, you can have different values which are maybe in a factor of 10, 1 or 100. We can still question the fact that does reference organisms really represent an ecosystem functioning. We don't take into account the bioavailability, the chemical toxicities, and also the microorganisms. And so there is globally a complete knowledge of the phenomena and the parameter of influence. So as a conclusion, I just wanted to show you that natural radioactivity and technically enhanced natural radioactivity is something complex to assess the impact on human and on the environment. We don't have all the biological model for organisms. There are a lot of parameters depending on human behavior. We have also facing in front of the problem of the memory of the risk for the long term, and also the trouble of modeling the interaction between life and radionuclide, what's going on exactly. We are missing a lot of models. So this is why we need this kind of long-term interdisciplinary research of our colleague. So I've finished with my presentation. I hope that if you have questions, or maybe we can keep the question afterwards, it's up to you. Thank you.
Merci, Patrick. Si quieren, ahora pueden hacer algunas preguntas o algún comentario, los participantes.
Silvia, tal vez si tienen algún mapa de radiación natural en alimentos.
Un mapa.
Sí, o sea, una concentración, tal vez identificado o concentraciones de elementos radiactivos naturales en alimentos.
Est-ce que vous avez identifié des concentrations dans des aliments? Est-ce que vous avez étudié ça? On t'entend pas.
Yeah, we carried out this kind of assessment. You can find very often that radium is really present in some specific fruit and vegetables. It's not really high indeed because people are not working exactly where it's the most contaminated area, but it shows that there might be concentration due to the species you cultivate and so on. But sometimes it may induce an increase of the dose to people. This is why it is important for us to assess the impact, is to know the people's habit. I mean, how much people are eating from their garden and so on. I mean, so the habits of people are very important in that case. I mean, for instance, for radium, we had something like 100 becquerel per kilogram in, I don't know the word in English.
Dis-le en français.
Des choux.
Ah, des choux?
Ouais.
Oh, punaise, comment on dit des choux? Coliflor? Se dice en Ecuador coliflor? Sí.
Cable, c'est pas cable, quelque chose comme ça, cable.
Ah, je sais pas, pero coliflor sí lo entienden, ¿no? Sí. Que había muchos, una dosis elevada en las coliflores. Oui, vas-y, continue.
That's all what I wanted to explain. Yeah. Okay.
Porque sería una temática, Yasser, que interesaría particularmente la alimentación.
En el país teníamos un proyecto con el Organismo Internacional de Energía Atómica para hacer levantamiento de concentración de radionuclidos en algunos alimentos.
Ouais, ça peut être quelque chose qui les intéresse. Il y a une question, hay una pregunta en el chat, ahora la voy a traducir, de Nicolas. Nicolas demande, dit que les bioindicateurs sont des organismes vivants qui grandissent dans certaines conditions environnementales et physico-chimiques. En tenant compte de cette définition, quels bioindicateurs peuvent être utilisés pour identifier des zones contaminées par les radiations?
So it depends of the compartment you want to study, but usually you use the mushrooms that are very good bioindicator because they concentrate the radioactivity. And in the water, you also use the shell, for instance, which also are filtrating all the time the water, so they accumulate the radioactivity. So it's a good way to know whether in the closer environment you have trouble with radioactivity. There's two kinds of bioindicator, but some are more relevant depending of the situation of the country and about what you can find in the area you're studying. But at least these two are very important. There are also the bryophytes, which are interesting for the air contamination because they have they also concentrate the radioactivity present in the air. So mushroom, bryophytes, and shell are quite good bioindicators.
C'est quoi? C'est les champignons et quoi d'autre?
Les champignons, les mousses et les coquillages, en fait.
Okay.
Enfin, les mollusques filtreurs bivalves.
¿Alguna pregunta más?
No sé si podrían ampliar un poco el tema de la ingestión de radón en agua.
Si tu peux un peu développer la question du radon, de l'ingestion de radon par l'eau.
Radon is very complex for every aspect. We are not sure exactly about the effect on a human being. Usually we consider radon for inhalation, not for ingestion. So it's something, at the moment we have difficulties to say what's wrong or not. In Europe, we have decided to say that water containing a higher quantity of 1,000 becquerel per liter should not be drunk. But it's difficult to calculate a dose. We are at the international CIPR. They are talking about to double the dose coefficient for radon. Everybody doesn't agree about this, so it's still something that has to be studied because it's a really complex gas for both aspects, not only for inhalation but for sure for ingestion. It's a really big question for us. What is difficult for in France for the radon legislation is that we have some part of the territory where you have a high concentration of radon in water. And the trouble, if you want to get rid of this radon, you have to agitate the water to make the gas get out. But this involves possible contamination with other microorganisms. And in a very little town or in the countryside, sometimes the cost of specific treatment might be not acceptable. I mean, in the financial aspect. So it's a little bit complex to manage the radon risk in certain area in France, even if I mentioned that the maximum activity is of 1,000 becquerel. And it also depends of the moment you use the water. If it's in the morning or in the evening, if many people are using the water at the same time or not, if the water was left in a tank for a long time or not, and so on. It's very difficult to identify, to characterize the risk for this radionuclide, especially for ingestion. Yeah.
Thank you, Patrick.
¿Algo más o pasamos a la siguiente presentación? Merci Patrick. Alors, on va donner la parole à Clarisse.
Sí, buenas tardes. No, es tardes para nosotros. ¿Ves la presentación? Sí. ¿Es ok? ¿No?
No lo vemos.
¿Aquí?
Ahora sí.
¿Sí?
Ya.
Voy a presentar en español, pero disculpe de errores voy a traer. Soy Clarisse Mallet, soy profesor investigador en laboratorio de microorganismos, genoma y medio ambiente a la Universidad de Clermont-Ferrand, como Patrick. Mi principal tema es investigación en la ecología, ecotoxicología acuática y edáfica. En este tema estudio la dinámica de las comunidades microbianas sometidas a limitaciones medioambientales, naturales y antropogénicas. Los objetivos generales son entender las respuestas estructurales y funcionales de las comunidades microbianas sometidas a estrés natural o antropogénico y las repercusiones en el funcionamiento de los ecosistemas terrestres y acuáticos. Los microorganismos, bacterias, arqueas, fungos y protistas, como podemos ver sobre las fotos, se encuentran y son predominantes en todos los compartimientos de la biosfera y también en los medioambientes muy extremos como los lagos termófilos, por ejemplo. Los microorganismos interactúan en todos estos ecosistemas para crear redes de interacción complejas dentro de que se intercambian materia y energía. Como podemos ver sobre este gráfico, la materia orgánica disuelta o particulada liberadas por las microalgas sean mineralizada por las bacterias que regeneran los nutrientes que contribuyen a los ciclos biogeoquímicos. Además, la materia orgánica que está hecha por los microorganismos del loop microbiano está transferido a los niveles trópicos superiores y permite mantener y soportar el red trópico. Entonces, entender el funcionamiento de los ecosistemas requiere, por tanto, identificar los microorganismos presentes y sus funciones y caracterizar también las redes de interacciones que constituyen. A su turno, la dinámica del medio ambiente constituye una importante limitación para los microorganismos que deben adaptarse constantemente a los cambios de sus hábitats. Esta dinámica intrínseca propia de cada ecosistema se ve hoy amplificada por las actividades humanas que generan perturbaciones de todo tipo. En este contexto me he interesado en las dinámicas de las comunidades microbianas sometidas a los pesticidas y radioactividad. Pero yo hoy voy a presentar mi trabajo sobre las dinámicas de las comunidades microbianas sometidas a la radioactividad. En este contexto exploro tres ejes. El primero, la emergencia de la vida, presteando al manifiesto la presencia de microorganismos, bacterias, arqueas y fungos dentro de pluma de volcanes en actividad. El segundo, los efectos de los radionúclidos en términos de radiación y de toxicidad química en suelos de antigua mina y de fuentes minerales. Y el tercero, las adaptaciones e interacciones implementadas entre microorganismos para mantenerse en estos medios. Para responder al primer tema, que es la presencia de vida en medio extremo y radioactivo, recorremos muestras en el plumo de humo del Etna, que está el volcán muy activo en Europa. Para ellos recogemos muestras directamente en el humo con placas de Petri estéril, con un medio de cultura general y con una aspiradora que aspira el humo. Las cenizas estaban recogimientos sobre placas de Petri también y directamente en tubos estériles para estudiar la diversidad taxonómica con técnicas de metagenómica. Los primeros resultados muestran la presencia de bacterias y fungos en todas las muestras, hasta en el humo, aquí, y al mismo orden de magnitud que en el aire ambiente. El segundo eje de mis estudios es entender los efectos de radionúclidos sobre los microorganismos, es decir, sobre la estructura taxonómica y funcional de los microorganismos, bacterias y fungos. Tomamos muestras debajo de la zona de almacenamiento en el mina de Roffin, que presenta un gradiente longitudinal de acumulación de radioactividad, como podemos ver aquí, el punto 0, 1, 3 y 5, y un gradiente de acumulación de radioactividad. Tomamos el sedimento del río, aquí, que viene por parte de la salida de la zona de almacenamiento. Habemos mostrado que la diversidad bacteriana, aquí, no está más importante en las muestras sin radioactividad. Las muestras sin radioactividad están aquí y las muestras que presentan más radioactividad están aquí. Y no hay diferente, hay una pequeña diferente, pero no hay más importante diversidad en las muestras sin radioactividad. La estructura de la comunidad bacteriana está diferente entre los muestros con radioactividad 5 y 3, que están muy separados de los otros sin radioactividad. Y para explicar esto, parece que se han separado por los radionúclidos como radón, que está aquí, radón disponible, pero no con uranio, que está aquí, y más por parte con los metales como cobre o hierro. El resultado es que hay otros parámetros ambientales que no habíamos medido y que explicarán más esta separación. Junto con este estudio, aislamientos de bacterias están efectuados a partir de sedimento y de agua con el objetivo de haber cepas de bacterias que pueden resistir al uranio para estudiar su interacción con él. Sabemos que algunas cepas de bacteria pueden transformar, es decir, reducir, mineralizar o acumular el uranio y modificar el hábitat donde están. Ahora tenemos más de 542 cepas de bacteria y vamos a estudiar la resistencia de 10 de ellas en laboratorio. Siempre sobre los efectos de radionúclidos, habemos también iniciado estudios en fuentes minerales que son muy numerosas en nuestra región. Presentan un gran gradiente de radioactividad y los ecosistemas que se han desarrollado en estos sitios están expuestos a la radioactividad desde muchos años. Nos aparecen como sitios muy interesantes para tratar de desvincular la acción de la radiación y la toxicidad química de los radioelementos de otros efectos como nitratos, materia orgánica u otros nutrientes sobre las estructuras de las comunidades de microorganismos en el sedimento y las biopelículas. Las biopelículas son muy importantes para los microorganismos porque ofrecen nutrición y protección contra estrés con la matriz de exopolímeros. Los radionúclidos pueden interactuar con la materia orgánica y creemos que pueden reaccionar con la matriz de polisacáridos, lo que disminuiría y inhibiría sus efectos. Es por eso que queremos también estudiar las adaptaciones expandidas por los microorganismos. En algunas fuentes muy radioactivas Perdón. En algunas fuentes muy radioactivas, como ellas sobre la foto, la sala, en la biopelícula hay diatomeas que presentan deformación de la frústula. La frústula es que es sobre las fotos, es la pared celular hecha de sílice. Estas microalgas crean alrededor de su frústula un medio diferente en términos de composición físico-química de la zona alrededor y que se llama ficosfera. Es en la misma idea que la rizosfera. Dentro de la ficosfera hay muchas interacciones entre diatomea y bacterias que pueden ser positivas o no por la diatomea. Por ejemplo, pueden permitir el crecimiento de las diatomeas a través de la disponibilidad de vitaminas o de amonio o de hierro y quizás protección contra uranio. Y es lo que queremos poner de manifiesto. Junto con el estudio de Gilles, que quiere saber las interacciones entre diatomeas y uranio, voy a estudiar la importancia de estas bacterias en el ficosfera y de estas diatomeas en fuentes radioactivas. Hoy está, no vos he hablado de los macroinvertebrados porque no ha hecho estudio sobre estos organismos y radioactividad, pero si quieres podemos hacerlo más tarde. Muchas gracias.
Muchas gracias. Muy interesante.
Disculpe con los errores y la pronunciación.
Gracias. Nosotros en Ecuador, en la UDLA, tenemos un grupo de investigación que justo hace macroinvertebrados acuáticos en ríos altoandinos.
Es por eso que quiero hablar de esos, pero no es con la radioactividad y con los pesticidas.
Sí. Nosotros
pienso que hay no sé cómo se dice, paralelo con pesticidas, los efectos de los pesticidas y radioactividad, pero yo no sé.
Sí, nosotros, el grupo de investigación investiga justamente el efecto de la erosión del suelo, de cambio climático, de contaminación orgánica e inorgánica en los ríos altoandinos en Ecuador, ¿no?
Nosotros también hacemos muchos estudios sobre el cambio climático y yo soy director de un máster de ecología acuática y enseño la importancia de los macroinvertebrados con bioindicador y en todos estos cambios.
Clarice, nosotros en Ecuador somos un país con mucha actividad volcánica, que es la primera presentación que tú hacías. Y tenemos volcanes activos, ¿no? Activos constantemente, no en erupción, pero están activos, ¿no? Con fumarolas activas. Sí, no sé si en base a la investigación que ustedes han hecho, se conoce un poco las concentraciones que podrían existir de radiación natural en material particulado de lo que sale de los volcanes, en esos aerosoles.
En el estudio sobre el Etna, yo no me recuerdo, pero en el humo hay una radioactividad del radón que no es muy importante, pero no es cero. Y habíamos hecho este estudio con colegas en un otro laboratorio de geología y habían mostrado que es muy importante el radiación el radiación y el radón en este humo. No sé si responder a tu...
Sí, sí. Aquí sería acá importante, por ejemplo, en Ecuador, mucho de ese humo, de esos aerosoles, al estar la mayoría de volcanes en la sierra, porque también tenemos en las Galápagos activos, este aerosol cae sobre los cultivos.
Ujú,
Y especialmente en cultivos de hoja ancha, como los que
ujú.
mencionaba Patrick, ¿cierto? En hortalizas de hoja ancha, que les gusta la radiación, ¿cierto?
Sí, sí.
Sabemos que les gusta la radiación a la lechuga, a la coliflor, le gusta la radiación. Entonces, en eso no hemos investigado, ¿no? Porque
Ujú.
normalmente sabemos que estos aerosoles tienen un alto componente de minerales que son buenos para las plantas, ¿cierto?
Sí, sí,
A largo
sí,
plazo.
pero
Nos da-
pienso que perdón, se puede ser muy interesante también de estudiar los microorganismos de los suelos porque se puede ser positivo, pero si estas partículas habían efectos, impactos sobre no sé, el ciclo de nitrógeno, por ejemplo, con nitrificación o no sé, se puede ser un efecto negativo por la producción del suelo. Y me parece que podría estar un buen estudio que hacer.
Muy bien.
Larissa, hay una preguntita en el chat también, no sé si la ves,
Mm,
que dice que para evaluar elementos radioactivos también se utilizan herramientas que miden luminescencia. ¿En qué se diferencia la fosforescencia de la fluorescencia?
Ula.
No soy capaz de contestar a esa pregunta.
Ah, yo no soy el jefe de los elementos radioactivos, no, yo soy únicamente biológica y ecológica, ecologiste y biologiste. Je t'entends pas, Silvia.
No sé si se dice ecologista o especialista en ecología y
Sí,
biología.
especialista en biología y ecología, pero no en evaluación de elementos radioactivos. Pero pienso que Gilles podría responder o Patrick.
Alors, c'est une question pour Gilles et Patrick.
In English.
Je la fais en français.
Ouais, en français, c'est
Pour,
bien aussi.
pour évaluer les éléments radioactifs, on utilise aussi des outils qui mesurent la luminescence. En quoi on se différencie la phosphorescence de la fluorescence?
Oh.
In English, please. Je ne suis pas sûre de pouvoir traduire là pour le coup.
Je regarde ça et puis je répondrai après.
Entonces dice que se lo van a pensar y luego contesta. Patrick también dice que On a un programme, tenemos un programa de estudio sobre radón en las columnas volcánicas de humo, porque puede dar muchas indicaciones sobre la talla de las, no sé cómo se dice, bolsas magmáticas de los... no sé si comprendes, Yasser, cómo se dice la poche, la bolsa magmática, ¿se dice así o no?
En el magma.
Sí, en el magma. Sí, comprenden que el estudio de radón en las columnas de humo da indicaciones sobre la talla de la capa de magma.
Ah,
No tiene ahí las medidas, pero sí que existe ese trabajo.
It must be the radon average that has been measured next to the volcano is more than 1,000 becquerel per meter cubic, which easily reaches 30,000 or this kind of value of radon activity next to the volcano. So it raises also a problem of radio protection for people who are working on this volcano, by the way.
À tes souhaits.
À tes souhaits.
Ah, pardon.
No sé si hay alguna pregunta más.
Gracias.
gracias.
Muchas gracias, Clarisse, fue muy interesante. Gilles Montavon, c'est à vous.
Merci, Madame Becerra. Okay. You can see the presentation, yes?
Yes, it's okay.
So I was looking about the definition of luminescence and phosphorescence. It's just a question of time. I mean, there is an atom which is excited by a photon, and then to go back to the fundamental state, it emits some light. And if the light is emitted immediately, it's luminescence. And if there is a delay in the emission, it's phosphorescence. Just to answer to this question. So I will now present you a project we are doing in the frame of this ZATU. And this was a work which was recently published in this journal, The Science of the Total Environment. So, I mean, okay, you know that you're interested in naturally occurring radionuclides. So this is what Patrick already told you, that there are different aspects that interest us in the frame of this zone atelier. So this question of effect on life, also to assess the behavior of these radionuclides and how they be transported or transferred, especially in food webs. And there is also an important aspect associated to the societal issues. And here I will mainly concentrate on what we are doing about this item, so the question of transport and transfer of radionuclides, which is an aspect which is directly related to the chemical forms of these radionuclides. This is what we call a speciation. And this is a work which has been done at the Rofin site. So Patrick already presented you this site rapidly. So this is a site which is located in the center of France. So here in the bottom you have information about what has been done on the site. So the site was mined in the 1950s. So this was the first site mined in France, and then it was rapidly closed because the concentration of uranium was not enough for I mean, with respect to the interest about the economic aspects. And then you see that there was 2 phases of rehabilitation in the 80s and in 22. No, 22. And you can see that this is actually the picture of the site. You can see that it's very difficult to see that there was an exploitation at that time. And you can only see the fence where you have the storage of the mine tailings. Otherwise the vegetation grew, and it's very difficult to see that there was an activity of mining activity at that place. And this is also why this site is very interesting for us, because I mean, if you look at the biodiversity, so there is a real interest to study this site, because there is almost nobody there, and it's an interesting site for this aspect. So this is on the left. You have the picture of the site at the time of the exploitation. We have different mines exploited, and the main one was the Rofin. Here you can see the settling ponds, and this is actually the picture today. And we did a gamma survey, and this is about 2 kilometers. And you can see, and this is the scale is in nanosievert per hour, and you can see that the geological background is about 50 nanosievert per hour. And here there is a place that interests us. This is a place where you have a relatively not important. I mean, there is a contamination, because you have about 10 or 20 times the natural background at this place, and this corresponds to a wetland. And you know that wetlands are places where you can sorb or trap the metals. And so this is actually the place we are interested in to study this place. And the question was, what about the origin of this contamination? Because I mean, you know that this is a place where you have uranium, so you can have a natural concentration of uranium, which can be completely independent on the mining activities. And the question for us was whether this is a natural concentration or it is an anthropogenic contamination. And to answer to these questions, we used different approaches. So in d'hydro analysis, radiochemistry, geochemistry, and history. And the idea is just to show you the main results associated to this work. So we start with the d'hydro analysis. So the idea here is to look at the concentration of uranium in the trees, of the rings of the trees. So we took oak trees, and here we take carrots of the trees on trees which were located upstream of the mine, the storage of the mine tailings, and we took also trees which are located downstream of this storage area. And so we selected a year before the exploitation, then 2 years during the exploitation, and then some years after the exploitation. And if you look at the trees which are located upstream from the storage, which are not influenced by the hydrogeological network, you can see that there is no real increase in uranium concentration in the tree ring. So it means that you see about nothing. And if you look at the trees which are located downstream of this mine tailing storage, you can see that there is an increase of the concentration of uranium during the exploitation. And then what is interesting also to see is that there is no decrease of the uranium concentration after the site was closed. It means that there is still some, the trees are still taking the uranium which is present in this area. And there is one tree which is interesting. This is the T5, which is located in a small hill, and it is not directly, it's not close to the creek. And you can see that here there is almost no variation of uranium according to the year. And this shows that the uranium was taken via the water in a bioavailable form. It was not taken by the trees via the leaves from air contamination. So this is from this first study, we can conclude that effectively there was a contamination of uranium during the uranium mining activities. So what about radiochemistry? So then we took also some core samples in the wet area, and this is a sample. There is it's about 100 centimeter in depth, and you can see that this is the concentration of water and uranium as a function of depth, and you can see that there is a relatively high peak of uranium, about 2,000 ppm at the surface of at about 10 or 20 centimeters from the surface. And this corresponds to a whitish area, which was not expected in a wetland where you expect to have mainly organic rich materials. So this was the first information. And then we took another core sample. And here you see that the resolution is better. And we took 1 centimeter layers. And you still observe, in this case, we observe 2 peaks of uranium with a concentration till 4,000 ppm. One located in this whitish zone and the other located in a transient between the whitish and the organic rich material. And then we also were interested to look to when it was deposited. And for that, we look at the activity of cesium-137, which is here. And this corresponds to the deposition of cesium-137 from the nuclear bomb tests, which were done in the 60s. So it means that this whitish material was deposited before the 60s. And this is totally in agreement with the time, at the time where the mining activities occurred. And this was also coherent with the datation from carbon 14, because you can see that this is an approximate value that this contamination occurred in the 1950s. So this is also coherent with what we expected. And then if you look at the ratio of the activities of uranium, radium, and lead, because they have different chemical behaviors, you can see that the ratio at certain places is close to 1. And this shows that uranium was transported in a particulate form during mining. So this information also confirms that this contamination comes from the mining activities and that it has an anthropogenic origin. So then as we expected to have some particles, we did some measurements by micro X-ray fluorescence at the synchrotron here in France. And you can see that you have effectively we found some particles of uranium. You can see this is the size of uranium. And we also, and we can see that where you have uranium, you have also lead. So you have a correlation between the concentration of uranium and the concentration of lead. And this was also totally in agreement with the fact that the uranium minerals which were mined were mainly uranium phosphate minerals, notably parsonsite, that they have in these minerals both lead and uranium. And this is also once more in agreement with the fact that the minerals which were present in this whitish material come from the mining activities. Then we did also some isotopic measurements, lead isotopic measurements, also for different samples taken according to the depth of the core sample. And these are the reference, the isotopic ratios corresponding to reference values. So it means that if you have a deviation from these isotopic ratios, it means that there is a contamination coming from mining, from anthropogenic activities. And this is actually the case for the highest contaminated zone, and also the case for the samples which were taken, which were relatively contaminated. And once more, this isotopic signature confirmed once more that this is a contamination coming from the uranium mining activities. And then Patrick took a lot of information from the archives, and we also took some aerial photography, which are presented here. So before the mining activities and after the mining activities, and you can see that during the mining activities, where we took this sample, where you have this wet land, you can see also this wettish material. So visually, you can also see that there was a material which come from the mining activities at the place where we took the core sample. And then there was a lot of documents which were taken by Patrick, notably from local authorities. And here I just give you a few excerpts to see that they also at that time showed some wettish material, especially in the creeks. There is this letter from the CEA where they said that the ponds were discharged into the terrasson, which is the creek, which is just downstream of the Rofin site. Here you have the setting ponds, okay, and they said that the stream was slightly turbid. And there was also a letter from the Châteldon town, which is also located downstream of the Rofin site. And they said that even at Châteldon, they observed some water which was completely white. And there is finally an inspection report in 1954. And they said that once more that there was a wettish stream water at Châteldon with the presence of mud. And all this information once more confirmed that there was a discharge of a wettish material containing uranium in the environment. And this is the reason why now we find this wettish material. And this is actually the hypothesis we are doing now, that this was before the exploitation, and this is now nowadays, where you have this discharge of this wettish material in the bed of the stream, and the stream now, the bed has slightly shifted, and now since that time, you still have now some soil rich in organic matter, and the vegetation grew. And when we took the core sample, this is why, according to the place where you are from the bed of the stream, the actual bed of the stream, you have the wettish material. The wettish zone can be the size can be different according to the place. So this is actually our assumption. And but we have also other information, and especially we did a detailed approach of the chemical forms of uranium in this wettish layer, indicating that since that time there was a change in speciation. So it means the chemical form of uranium is no more in a form of mineral forms, but we think it's mainly adsorbed on clay particles. And this was also confirmed by in situ measurements. Here we don't go into the details. I mean, just to show you that we think that there was a change in speciation from that time. And this is something we want to understand. And we think also that the colloids, which are the small particles which can contribute in the transport of the nuclides, they can play an important role in the transport of uranium. especially because you have a lot of iron oxide colloids, but also organic colloids. And also there are some pending issues. If you look at, as I told you, I mean, we understand why there is this concentration of uranium in this whitish layer, because it came from the discharge of these setting ponds. But we have this peak, which is present here in the organic rich material. And we don't know the origin of this uranium. And this is something we still have to understand, why there is a second peak. And now if you look at the rings, which were where we measured also uranium concentration in the rings in 2011. And you can see that you have still an increase of uranium concentration. So it means that there is some uranium that is transported in the environment, especially in the watershed, and which is taken by the trees. So it means that there is a dynamic in there is a transport of uranium nowadays, and this is something we have to understand. And even if you look at the trees, which are located upstream of the uranium mine, which are purely not influenced because we are upstream of the hydrological network, there is also an increase. So probably there is also a contamination of uranium by dust, by the air. This is something we cannot understand why there is actually this uranium concentration in this tree ring. And that's why now this is actually our program, because in the Zatoun Atelier, we have program of 5 years, and every 5 years we have to renew this research program. And this is one important aspect or objective of this research program is to propose a first version of reactive model at the wetland scale in order to understand or to describe the behavior of uranium, and especially the link between the wetland and the creek. And for that, of course, we need a lot of information, especially the description of the hydrodynamic of the system, how we can represent the soil and sediment layers in this wetland. We also need the information about the geochemistry, the mineralogy, water composition. We also have to introduce in the model the parameters describing the behavior of these radionuclides. So especially the KD value describing the retention, the capacity of the soil to retain the uranium and the decay products. We also would like to introduce in this model the transport of uranium in the plants, and to integrate also in this model the possible effects or the influence of colloids in the transport of these radionuclides. So they're really a challenging work to be done, and because there are a lot of data to be measured, and also for the modeling, there was also some important aspect to develop. And of course, the idea is to introduce this data and then to predict the mobility of uranium, and then to see where uranium can be transported, and then to check afterwards whether the model can explain the dynamic of uranium at the scale of the wetland. So for the moment, we're interested in uranium, but we also would like to introduce the chemistry, the behavior of radium also in this model. And this is to finish all the people who are involved in this research program. And you can see that they come from so universities, the National Center for Scientific Research. So personally, I'm a senior scientist from the National Scientific Center for Research. And there is also people from BRGM, CA, IRSN. And also we have a collaboration with people from Germany. So, and finally, I would like to thank you for your attention.
Gracias, Gilles. Tu as une question de Raza dans le chat directement. Je ne sais pas si tu la vois.
Mm-hmm.
Hello. I'm sorry. I was thinking maybe I can turn on the video, but it it just went away. I cannot see. So first of all, very interesting talk. I was a little bit surprised. I mean, I don't really know much about the radioactivity and how it gets into the plants. But the thing that you say it doesn't go through the air and through the leaves, but it goes through the water is very interesting, actually. And another thing, so my question was that you think it leaks maybe with the rainwater into the soil, the radioactivity, like a uranium. And then in time, it goes deeper and deeper. I guess that was my question. I don't know if it makes sense or not.
Yeah, no, it makes sense, but for the moment I cannot answer to your question because first we really need to understand the interdynamic of the system. Where is the water table? Whether there is some deep water, and this is something, and this is actually an aspect where we are analyzing. So we are instrumenting the site with the piezometers, notably, in order to see where is the water and how it behaves. And then this is actually the first information we need. And from this information, then we could understand the behavior, or we could at least try to understand the behavior of uranium. So yes,
of course.
It's interesting, but I cannot answer now to your question.
Of course, and then the things that you find that in 2009, I think it was an 11, the concentration starts kind of growing up, like increasing. That's also interesting. Would that have to do maybe with some environmental changes, maybe getting warmer, or I don't know.
Yeah, this was very strange. Yeah, so these are very strange, and I hope that it will be possible to answer to the question. But
and that is the tree. That's the ring of the tree in 2011. It has more concentration of uranium.
Yes, yes, and also.
And you have in the other plant too, in the T2, you also have 2011 like a highest peak.
Yes, yeah, especially for the T2 because T2 is upstream.
That would show that it maybe if there is an underground water, like it flows either way. I don't know.
Yeah.
Interesting. Yeah.
Yeah. I
and
don't know.
T5 as well, the concentration at 2011 is more high than any other one. Very interesting. I wonder if it has to do maybe a little bit with changes in weather. I know 2011 was not a year of El Nino, but of course El Nino is not European climate, is a little bit different. So that would be interesting maybe to see. Because starting 2000, you get more and more hot years every time. So maybe environmental parameters have something to do. Very interesting.
Yeah, and we hope that with the model, it's possible to model at least the level of the water table. It depends on the tree, on the rain. We also have an installation of some sensors in order to measure the rain. And then
maybe it was a more rainy year or something. Another question, did you maybe do any other sites like a little bit further from these dig sites? Maybe like a, let's say, background, like one T0 that you would have that's further, so that you would be able to eliminate that it's a local effect or not a local effect?
Yeah, but for us, the reference trees were T1 and T2.
Oh, okay.
But it seemed that we were not, we were too close from the mining activities. Yes, and you're right, perhaps it would be good to have, especially for the trees, to have a tree which was, far from this.
And also the elevation, I see you have a terrain, and also maybe the wind direction kind of also eliminate that maybe it would be going through the leaves. So choose like do a wind rose for that area to see prevalent.
I know you are expert in transport.
It's very interesting to see all the parameters, and with machine learning you could work eliminating certain things and say, oh yeah, this one doesn't have anything to do. But if you choose like maybe in few different directions and a little bit further and see what is going on with the concentration, maybe it could be interesting. I don't know.
And also we have a lot of data from radon.
Yeah.
in this site. And for the moment, we have not yet tried to. We are collecting the data, so we could also model the behavior of radon according to the parameters describing the behavior of the
Yeah, very interesting. Very nice. So I will take over Alejandro because he had to go to another meeting. So I don't know if there's any other questions. ¿Hay algunas otras preguntas de los chicos sobre esa presentación? I don't think in the chat there's any questions. Let's see.
Okay, thank you.
Yeah, there's no more questions. Thank you. Sorry, I completely occupied your question part. I don't know if we have another presentation.
Sí, perdón. Ahora le toca a Sylvie.
Yeah.
Hello.
Hello.
Okay, I have to. Okay, écran. Okay, so I'm Sylvie Huet. I'm working in Auvergne, the same town as Gilles and Patrick, in this volcano region. And I'm working in IE, which is an institute much more dedicated to research in farming and environment. I'm a computational social scientist, and I give you some clue of what are the subject I study. It starts from innovation diffusion to by change of agricultural practices, demography, and so on, using dynamics models such as agent-based model, for example. So I was accepted in the ZATU group quite recently, and I have begun a study of the impact of uranium mine on the development of rural small cities in France. So I have a bit changed my mind compared to what you have previously seen, trying to have an overview of what is the socio-economical impact on the presence of these mines. So in France, it has been operated 241 mines during from 1945 to 2001, and they are mostly located on the center and much more on the east of the France, as you can see on the map. At the beginning, when the first one has been opened, the radioactivity and the uranium benefited from a very positive social image. I mean, it was at this moment after the Second World War, an idea of national autonomy, better health, innovation, and progress behind the fact that the uranium has to be used. So people thought, as it is classically the case when a new industry comes, that having a new uranium mine would permit to maintain the local employment and to favor the local development at a moment where in France, people tend to quit a lot the countryside to join the cities. And from the 50s to the 80s, a large part of the country in France has been desertified due to this dynamics. So I wonder if having an uranium mine has changed this desertification tendency in France. So I asked about the impact, and two possible answers was possible in terms of the impact of the presence of a mine. We can first assume that there have been the cities where they have benefited from the mine and has continued despite its abandon to economically and demographically develop themselves. Or on the contrary, we can assume that they have economically and demographically decreased after the closure of the mine. So I tried to address this question with a quantitative approach, formulating two different questions, which are at first, have cities with an operated or an abandoned mine developed more than other cities? And the second one, what it is interesting to me is, does the surrounding to a mine cities benefited from the presence of it, and also when it is operated and after it has been abandoned? So I have to collect many data in order to constitute a sample. And in this sample, there are data from the various censuses of the population at the city level from 1946 to 2017, and especially the local evolution rate of the population, an old age indicator, and an household revenue. In the Mimosa database, which is the database for France, which described many information related to the uranium mine, I kept the location of the mine as well as the beginning and the ending dates of their exploitation. And then finally, I take the geographical coordinate of the city in order to compute the distance between them. So first, finally, I have a database with, for each city in a label indicated to me at a given date if it has an operating mine or an abandoned mine, or if it is without a mine, and in this case, what is the distance to the closest city with the mine. So first, before looking at my result, just look at the characteristic of the sample we use. There is here a distribution in terms of population size of the city at the beginning of our phenomena in 1946. And we compare the city of the sample, city having a mine after 1946, and city never having a mine. So what you see is, from a general point of view, you can see that on average, the size of a city in France is very small, about 1,000. And you can see that we have a bit more, a bit larger cities in the bunch of cities having a mine compared to the bunch of cities having no mine. So in order to keep our cities comparable, I just take the cities having less than 15,000 inhabitants, since the maximum size of a city having a mine after 1946 is 14,400. So finally, I have 172 cities with a uranium mine to compare to about 35,000 cities with no mine. Regarding also the sample, I visualize the altitude of the cities with mine. We can see the graph on the left, and you can see that our city with a mine are located mostly from 4,000 to 700 meters, which correspond in France to what we call a median mountain altitude. And then also on the right, you can see how the what is the speed of the opening mine process over the time. Then if you follow, so this is in percentage of the total number of cities having a mine at the end. And what you can see following the dots on the graph is that very few mine has been opened at the beginning in the second part of the 40s. And then suddenly you have a lot of mine which has been opened in 50s. And the number of new mines tend to remain stable from 60 to 80. And in the 80s, you have a second step of a strong increase of the number of mines until 2000, which is the moment where every mine has been closed, abandoned. From a methodological point of view, I have to address my two questions regarding the impact of uranium mines on city where mine site is located. Then I will compare directly the city having a mine against the city having no mine. I want also to address what is the effect on the cities located around this city. So not necessarily the city with the mine, but the one which are close enough. So in other words, what is the effect of the distance to a uranium mine? And so these two questions, I would like also to address the issue of the temporal evolution of the comparison between the two, having no mine or having a mine. So let's see the result. Firstly, we are interested in comparing cities with mine versus cities with no mine. What you see here is on the x-axis a different period of time, and the y-axis represent the evolution rate of the population at the city level. You can see that that globally in France, until the 80s, the evolution rate of the population tend to be negative in this small city we had in the sample, and then become positive. But if you compare the cities with no mine, which are represented in black, against the city with the mine, whatever is operated in red or abandoned in green, you can see that the city with no mine has a more positive evolution rate than the city without a mine, sorry, has a more positive evolution rate than the city with a mine. So the mine here has a negative impact. And the impact is tend to be as negative whatever the status of a mine, operated or abandoned. You can see more. You can, from a temporal point of view, you can distinguish 3 periods. A very first one till 1954, showing that the very first mine has a positive impact when they are operated in red. But after that, the impact was always negative, but 10 degrees starting from 1999. Then I have investigated a second indicator, which is the old age indicator that you can compute considering the part of the population being more than 75, of the part of population being less than 20. So it gives you an idea of what is the part of old people in the population compared to the young people. So here again, on the axis side, you have the time and the value of the indicator for different cases, in blue for cities without mine, and in red and green for city with mines. You can see again that over the time, the indicator tend to increase, but that in any case, the city without mine are less impacted by the aging of the population compared to the city with mine. So it has been confirmed also, you can see on the right, from a statistical point of view, these results are significant. So third indicator, which is the average revenue of household at the city level for a year in 2011, you can see that if you compare the blue bar, which represent the city without mine, to the red one, which is cities with an abandoned mine site, you can clearly see that whatever the type of household we are looking at, the revenue is larger for cities without mine. And this is also significant from a statistical point of view. So let's see now the second question, which is, okay, we have seen that the presence of a mine has a negative impact on the city where it is located. But how far this negative impact is diffused? Has it an impact on the surrounding cities? So we are looking at the same indicator, but this time considering, as you can see on the x-axis, the distance to the closest closest city with a mine in kilometer. And then you have, sorry, you have on the y-axis the evolution rate of the population at the city level for different periods. And you can say that this is the evolution rate tend to increase whatever the period. This means that the further the city is from city with mine, the larger is the evolution rate. So you really see how far the negative impact of the presence of a mine diffuse over the space. So it has been continued. If you look at the right table, you can see that it has been confirmed compared to the impact of the altitude of the city and the initial size of the population of the city. The impact of the distance to the closest city within a mine is statistically significant and relatively important the classical impact of attitude and size of the population at the beginning. The same for the old age indicator. If you represent its evolution over the time and for different distance to the closest city with a mine that you have here, you can see that it tends to decrease with the distance, indicating that the part of old people tend to be lower and lower with, at the moment, the distance increase. So the further you are from a city with a mine, the lower is the part of old people compared to the part of young people. Again, it has been statistically confirmed compared to the effect of the population size at the beginning and the altitude. And finally, the same for the revenue in 2011. You can see here that this average revenue tends to increase with the distance to a mine. So the further you are from a mine, the higher is the average yearly revenue for an household. And also it is significant globally and in comparison to other main factors such as altitude and the size of the initial population. So in order to have an idea about the temporal evolution of the effect of the distance to a mine, I'm looking at the evolution of the value of the beta coefficient in the regression. So what you can see regarding the blue line, which indicates the evolution over the time of the beta coefficient for the evolution rate of the population, you can see that the effect of the distance tend to increase until 1982, and then it tend to decrease since then. But it still exists, and it is still significant from a statistical point of view. Regarding the effect of the mine, the distance to a mine on the old age indicator, you can see that the coefficient has increased, in fact, since it is negative, a lot until 90, and then it remained more or less stable since this moment. Okay. So even if regarding the population rate, we have the feeling that the negative impact tend to decrease, this is not so much the case regarding the old age indicators and probably the revenue indicator. So finally, what we can remind for this work, we can remind that not only the development of cities where there is an uranium mine site has been impeded, but also the one of the surrounding cities. The negative impact of the uranium mine on the local development is surprisingly not really depending on the fact that the mine is operated or not. And the negative impact still exists even if some indicators tend to indicate it decreases. From reflection point of view, I would say that this result challenges the classical approach, which assumed that the economic welfare linked to the exploitation of a mine compensates the associated risk and help the local development. It means that perhaps it is just a belief, at least regarding the uranium mine. And regarding different sources of literature, it appears that perhaps this result can be better explained by the global image of the radioactivity over the time in France on the first hand, and on the second hand, this is possible that the decrease of the negative impact over the time that we can see on the population rate is only due to the fact that since the mine has been closed, people has acted in a way that they tend to forget the presence of the mine. So it confirms, in a way, the need to study how they are socially, how uranium mines, uranium residue are socially perceived in terms of belief and value by comparison to biological and physical measures to understand their impact. Thank you.
Thank you, Sylvia. Very interesting talk. I don't know if we have any questions. ¿Algunas preguntas, chicos, sobre esa presentación? Sometimes students are more shy. I don't think there's any chat message. I have one question. So all the negative impacts is very interesting. Do you know like a social reason, because people are aware of the radioactivity and the health issues? That's why it's maybe less attractive, or younger people in general are moving to bigger cities. What could be the reasons of these negative effects, basically, of the mine?
Mm-hmm. I would be very happy in the next day to investigate this. Have few clues regarding that. I know that in France, when you ask to someone if he accepts to live close to the
mine,
radioactive plant,
okay.
They answer no, in about 95%.
Of course.
So perhaps we can think that depending on the image of the social image of the radioactivity and the perceived risk associated to it, people don't want to live in this place, which would be confirmed by results such as the probability to move in a city depends on the distance to the mine, for example. And the second, so this is moving in. There is also something regarding the fact that perhaps people quit much this city than the other cities. But regarding other indicators such as, for example, revenue, this is probably that these cities suffer from a lack of dynamics, which is perhaps associated to someone which has been pointed out by the literature and by the experience that, for example, Patrick has talking with these people living close to the mine. They are quite ashamed of their city. They have kind of shame patrimony.
Another question, have there any works been done, like if you have a uranium mine, whether it's active or not active, any difference in radioactivity in that area, like an actual reason to want to live there or not want to live there? Like if there's a mine that's not active, it's like the same as living in a city that doesn't have a mine. I wonder if there's any work done on that, kind of like in a radioactivity map in those regions?
No, I think that this is what Patrick and Gilles tried to show you. To my knowledge, you have no map. Nobody says, nobody really knows what is the level of the radioactivity and the associated danger. This is what they tend to measure and to define, if I have well understood. So it means for me that in a way the phenomena that we have observed regarding the impact of the distance to a mine is purely social, but trying to understand how a real knowledge about the physical and biological measure of the radioactivity interact with this phenomena when people have the information.
Of course, and the city is not like a mine is right in the middle of the city. It's
for the moment, the reason for the phenomena is not a precise information. It is much more due to a global impression about radioactivity and its danger due to important accidents such as Fukushima, for example. So people think generally that it's very dangerous, but they do not know exactly where and how.
It's a very interesting topic in general, and it seems like it's very necessary as well, the work that you are doing, that your group is doing. I don't know if anybody, Patrick or Jill, want to comment on this or add to this.
I just wanted to say also in France that there is a big debate of the way to name everything. Usually we talk about radioactive waste or nuclear waste for any radioactive material, but for natural occurring radioactivity, for instance, like what we can find with the residue next to the mine, we just talk about residue. We don't use the word waste in France. So there is also, even if the danger might be nearly the same as artificial radioactivity, or we are still, we split the waste between two kinds of waste, the one coming from the nuclear industry and the residue coming from the mining operation. It's purely a way to design something, to give a name to something, but it means a lot for people because they are not aware that they are next to waste. Indeed, they are next to residue. It's a different perception also. And something also that is important also in France, that the mining shutting down doctrine was developed after the last uranium mine was closed. So every mine has not been really assessed with the rule we could use nowadays, and we have now to manage with the consequences. We have also to be aware that the waste, the residue, will be radioactive for several thousand years. So it's something that is important to keep in mind for the memory, also for the future generation, that there might be a risk in specific area. It's also an issue for us with all this work.
That's kind of another thing that I was wondering, thinking, okay, if you have a town that has a mine, how does it look? Is it like a big hole? Something that I don't really know. Is it also kind of an attractive? It's something that you have in your region that is a big hole that is unattractive. That might be also another reason why it could have those negative issues, or it's more psychology, or it's actually proven that it's more radioactive. It's like what kind of parameters are actually influencing. It's very interesting. And a lot of mines. Oh my God, the map? A lot of mines. The map.
Yeah, but most of them have been operated just for a few years, you know. But there are a lot of mine sites in France.
A lot, yeah. I mean, it's a big country as well, and it's very impressive. Okay, if there's no other, en Francia existe un mapa de riesgo de radón en zonas de color que indican el nivel de riesgo. Thank you. Another presentation. We can move on to another presentation.
Sí, es la mía, es la última. Bueno, si no hay preguntas. Bueno, pues entonces, a ver, yo, como les decía, luego he estado llegando a la zona taller hace muy poco, entonces no tengo así como resultados para presentarles lo que he podido hacer hasta ahora o no es significativo. Entonces me pareció interesante compartirles el tipo de trabajo que hicimos en el Ecuador justamente en un programa de investigación que se llamaba MONOIL, Monitoreo Ambiental, Salud, Sociedad y Petróleo en el Ecuador, que finalizó en el 2018. Entonces partimos de la idea que la explotación petrolera, que es base de la matriz energética mundial, pues es ampliamente debatida y más con el contexto marcado por los cambios climáticos y globales. Pero por el contrario, las condiciones de vida en los territorios donde se extrae pues no eran mediatizadas, ¿no? Entonces, era importante para nosotros investigar lo que llamamos una ambigua experiencia social de estas actividades en un territorio donde se tienen que compartir la tierra, las actividades petroleras y las actividades agrícolas. Entonces, nuestra pregunta fue de saber cómo concretamente vivían los moradores con los daños, impactos y riesgos relacionados con las actividades petroleras. Y cómo lo... ¿Sí ven mi pantalla o no? A ver.
Sí.
Sí saben,
Se ve la pantalla.
Ok. Entonces, bueno, cuando vamos a la Amazonía Norte, pues son paisajes de barriles, de tubería, de mecheros, de pozos, pero también hay una contaminación que es más silenciosa, que son las piscinas de petróleo enterradas o cubiertas solo así de vegetación y que son una contaminación global, pero que no se ve. A pesar de su rol en la economía del país, pues en la región amazónica ha sido una de las más pobres y más amenazadas desde el punto de vista social y ambiental, como los trabajos de Carlos Larrea de la Universidad de Andina Simón Bolívar han demostrado. Él hizo un atlas socioeconómico de las desigualdades en la Amazonía, que es un importante trabajo, bueno, que abarca todo el país, pero también la Amazonía, ¿no? Entonces, en esta área lo que es importante precisar es que son 80% de los recursos del país, pero en un territorio donde está concentrado solo 5% de la población, y que estos 5% viven en niveles de pobreza mucho mayores que el resto del país. Entonces, claramente han sido identificados impactos acumulados de esa actividad petrolera, ¿no? En el ambiente, la salud, en la cultura e incluso en el desarrollo económico, pero partimos de la idea que son impactos positivos también los que han habido y que no se podía solo mirar las cosas de un punto de vista, como se dice, de una hipótesis de impacto negativo o solo negativo, ¿no? Porque, por ejemplo, hay creación de empleo en esta zona que es bastante importante. Hay riesgos de accidente, ¿no? Pero también riesgos a más largo plazo y más invisibles. Y había en esta situación, vamos a decir, había poco conocimiento sobre los impactos y riesgos ambientales, tanto a nivel de fauna acuática, por ejemplo, que a nivel de riesgos a la salud. Y eso fueron un poco los objetivos de este programa Monol. Entonces, caso ecuatoriano era representativo para nosotros de uno de los principales retos de las sociedades actuales, que es vivir en un ambiente para siempre contaminado, en un mundo intrínsecamente peligroso, pero donde los peligros, donde los riesgos no necesariamente se ven y donde muchos son irreversibles. Estamos en una era donde el paradigma político central es adaptarse a los cambios sin necesariamente poner en discusión las causas profundas de estos cambios, ¿no? El requerimiento central es vivir con los riesgos y dicho de otra manera es el hecho de organizarse hoy para gestionar mejor lo que va a ocurrir en el futuro y las incertidumbres. Se suele decir, por ejemplo, que un riesgo, que el hecho de percibir, de tener conocimiento sobre un riesgo, permite protegerse, tanto a nivel personal como a nivel colectivo. Pero, y de hecho, la ausencia de esta percepción, pues, induce vulnerabilidad. O sea, la percepción sería la base de lo que las teorías sociológicas llaman cultura del riesgo, y que sería la garantía de una reducción de la exposición a fuentes de contaminación. Pero esta afirmación tiene ciertos problemas. Primero, que el vínculo de causa a efecto entre las percepciones de un problema y la respuesta a este problema no es directa. Tomen solo el ejemplo del cigarrillo. Ustedes pueden saber que causa cáncer de fumar cigarrillos, pero sigue fumando, ¿no? Y otro problema es que las personas se enfrentan a muchos riesgos diferentes en su vida y no solo a los meros peligros de su entorno. Se enfrentan a riesgos incluso más tangibles a corto plazo en comparación con los riesgos invisibles y a largo plazo, que son, por ejemplo, el riesgo de enfermarse debido a una exposición a contaminantes ambientales. Entonces, a pesar de los cambios que han habido en 60 años de explotación petrolera en el país, la experiencia social que encontramos cuando llegamos allá en el año 2012-2013 era que era siempre lo mismo. Toda la gente nos decía que todo estaba contaminado y nosotros preguntamos cuál era la realidad de esa afirmación de la gente. Y entonces la pregunta era de saber cómo los habitantes de estas zonas percibían y vivían con los impactos y riesgos de las actividades petroleras. Y nuestro objetivo a nivel sociológico, hablo porque no les voy a hablar del todo de toda la parte ambiental, que es súper importante también. Yo estoy aquí solo hablando de la parte sociológica. Nuestro objetivo era caracterizar y comprender la experiencia social de la contaminación ambiental y de los riesgos sanitarios, estudiando esto que llamamos cultura del riesgo, que sería un vínculo entre la experiencia pasada y actual de la gente y la visión de su vida futura. Entonces, trabajamos en Sucumbíos y Orellana, en las dos provincias del norte, en una perspectiva desde el comienzo de las actividades petroleras hasta ahora. Y yo, bueno, a nivel sociológico hicimos más de 160 entrevistas a profundidad con moradores de varios pueblos, comunidades de esa zona, y desarrollamos también lo que hemos llamado un índice de cultura del riesgo, que sería un acercamiento a los datos cualitativos para poder transformarlos en datos cuantitativos. Ahora me explico. Este es el índice de cultura del riesgo. No voy a entrar en el detalle de este índice, pero solo que quisiera decirles al menos que está compuesto de 4 indicadores: conciencia, el hecho de vivir con las actividades petroleras en la práctica, las visiones del futuro y el contexto y las condiciones que van influenciando las percepciones de la gente. Porque suponemos que no solo lo que estamos viviendo nos influye en nuestra percepción, pero toda la trayectoria de vida que tiene la gente, la experiencia que han tenido con otros tipos de riesgos, otros tipos de accidentes, también les podían influir en su visión de las cosas. Entonces, este índice fue compuesto de 12 indicadores y cada indicador fue anotado con una puntuación de 0 o 1, y entonces cada persona que entrevistamos obtuvo una puntuación sobre 12 que indicaba su nivel de cultura del riesgo. 12 sería la nota más fuerte, el índice más fuerte, y 0 sería el índice más pequeño. Entonces, no voy a entrar como lo digo, en los resultados, pues que son muchísimos. Solo, por ejemplo, mostrarles lo que resultó. Por ejemplo, el hecho de darle una puntuación a 4 grupos, 4 grupos sociales, 2 grupos mestizos y 2 grupos indígenas. Los mestizos eran de 2 parroquias diferentes y los indígenas eran de Dayuma, ya que ahí solo pudimos trabajar.
Silvia,
entonces, ¿sí?
No vemos.
¿Cómo que no ven?
Sí, quería
Vemos
comentar
solamente
sobre la primera página.
una diapositiva.
Solo primera página. Ahora parecía que estabas mostrando como mapas o...
No comprende por qué no se ve.
Solo podemos ver la primera página. Eso también, cuando ya empezó a dar las vueltitas, Silvia.
Pero no le ven ahí, no ven no ven nada desde que estoy hablando.
No, estamos viendo la primera página que dice nuestro vivir en la Amazonía.
Pero solo eso.
Sí.
Ajá.
Pero ¿por qué no me lo dijeron antes?
Porque no sabemos.
No sabíamos porque pensábamos tú puedes verlo.
Sí,
y cuando diste la vuelta alrededor, como parecía que muestras 2 grupos, yo digo, no, creo que no.
Por favor, pero yo estoy hablando estoy mostrando diapositivas desde hace un momento. Entonces, por favor.
Porque sí se ve la primera página, sí se ve.
Ahí sí.
No, ahí cuando hago esto no le ven.
Ahora se ve. Ahora sí se ve.
Ahora moviste, están unos barriles ahí y unos válvulas.
¿Y ahora?
Sí.
Ahora sí
es
se
bueno.
ve la barrel, flare and oil.
¿Sí ahí lo ven?
Ahora sí vemos, pero no veamos los 2 grupos que estabas hablando de indígenas.
Ahí están. ¿Los ven ahora?
No. Todavía se ve barrel, pipe, flare, oil, well, landscapes.
Tu es uniquement sur la diapo 2 et tout à l'heure tu étais bloqué sur la diapo 13.
Se demora a cargar. Estamos viendo diapositiva 2.
Bueno, un momento. Oh là là, mais franchement...
No me
antes yo pensaba, wow, está hablando muy bien con una diapositiva, pero cuando empezó a hablar de 2 grupos diferentes, yo no creo que tenemos que ver algo diferente.
¿Y ahí ven o no ahí?
No.
Todavía no.
Alors, un momento.
J'ai l'impression que tes diapos sont un peu lourdes, ¿no?
¿Ah, sí? ¿Ahí ven o no?
Screen sharing.
Sí.
Ahora sí.
¿Y ahí sí ven o no?
Ahora sí.
Oui.
Bueno. ¿Ahora ven el gráfico o no?
Sí.
Sí.
Bueno, pues ese es el índice de cultura del riesgo de que estaba hablando. No sé si hay alguna otra.
Sí.
Bueno, ahí nos quedamos ahí. Este es el índice que decía con las los 12 indicadores. Y aquí era una representación de lo que podíamos sacar de ese indicador cuando sumábamos todas las notas de, por ejemplo, el grupo de los mestizos de Pacayacu, sacábamos este tipo de estructura que nos permitía ver el nivel de influencia de cada variable en el índice final. ¿Sí me comprende? Por ejemplo, la variable conciencia era la que más influía en la puntuación global de este grupo. Sí. Mientras que, por ejemplo, en el grupo Shuar o Quechua, era el hecho de la experiencia práctica, las actuaciones reales, las que influían en el nivel de cultura del riesgo. Y, por ejemplo, aquí se veía que, por ejemplo, las poblaciones indígenas, en todo lo que era visiones a futuro, tenían muchas dificultades para tomar una posición respecto al futuro. Y eso se explicó por el hecho que tienen una consideración del tiempo que es totalmente diferente de la consideración mestiza, por tener una concepción circular del tiempo y no lineal de pasado, presente o futuro. Entonces, bueno, podríamos decir algo, hemos demostrado que había influencia, por ejemplo, del hecho de trabajar en una petrolera, pues influía, estaba correlado con el hecho de tener un índice más elevado, el hecho de estar en un grupo político, de tener una especie de movilización social en su vida cotidiana también estaba vinculado con tener un índice más importante, etcétera, ¿no? Ahí ven la diapositiva, ¿sí?
Sí.
Bueno, ahora funciona, parece, ¿no? Entonces, ¿qué ponemos de evidencia un cierto número de resultados? Sí que vimos que había una conciencia clara, una percepción de los riesgos ambientales y sociales, sanitarios que podían estar vinculados con las actividades petroleras, pero que sobre todo desembocaban en lo que los autores Aullero y Suitzun, que han trabajado en Argentina en problemáticas similares, llamaban sufrimiento ambiental. La diferencia con lo que pasaba en Argentina, pues es que aquí es un territorio que es también un territorio agrícola y que de hecho la contaminación parece ser más aceptable en un territorio si las tierras son cultivables y fértiles para la agricultura. Todo pasaba como si había una clasificación de los riesgos y como si un tipo de vulnerabilidad, por ejemplo, la vulnerabilidad sanitaria, podía ser minimizada por otra vulnerabilidad que sería la vulnerabilidad, por ejemplo, profesional o identitaria. Porque, por ejemplo, los agricultores, había cosas un poco paradójicas como si le preguntábamos a la gente si querían salir, si podían salir de la finca y habitar en otro lugar, qué es lo que harían, a dónde irían a vivir. Y, por ejemplo, contestaban que iban a vivir a Sacha o Xuxufindi, donde se demostraron altos niveles de contaminación ambiental y de problemas sanitarios. Y la razón de eso era que allí la tierra era tierra negra y fértil y que allí sabían que podían jugar su papel de agricultor. Entonces, el hecho de conocer el riesgo no siempre significa actuar y protegerse. Hay comportamientos y saberes que son antagónicos y que coexisten en las mismas personas, en las mismas familias, en los mismos grupos. Así pues, una familia puede estar protestando o poniendo de queja a la actividad petrolera, incluso en el tribunal, pero mandar su hijo a trabajar en una petrolera cuando tiene la oportunidad. De hecho, el hecho de tener una fuerte puntuación de cultura del riesgo no necesariamente corresponde a estrategias de reducción de la exposición a los contaminantes, y nuestras investigaciones mostraron que a pesar de este conocimiento, puede haber un empeoramiento de la exposición. O sea, es lo contrario de lo que generalmente se dice, el hecho de percibir el riesgo nos permite protegernos, pues aquí el hecho de percibir el riesgo a veces estaba vinculado con una exposición más amplia todavía, debido a necesidades, por ejemplo, laborales o financieras. Luego también hay diferencias entre las poblaciones mestizas e indígenas, y por ejemplo algo interesante era que los indígenas veían los riesgos más vinculados con peligros de la selva, como la picadura de insectos o de animales, que tenían para ellos una importancia mayor que los riesgos a largo plazo de una exposición a contaminantes petroleros. Bueno, en fin, para concluir, vimos que la cultura del riesgo era más bien una capacidad a manejar diversos riesgos en su vida cotidiana y a transformar ciertos de ellos en oportunidades, pero no necesariamente a evitarlos. Entonces, ahí ven lo que pudimos hacer allá. ¿Cuáles vínculos podría haber con el tema de la radioactividad? Como lo decía la compañera antes, pues no más que se habla de radioactividad, surge el miedo de la energía nuclear. Generalmente hay una percepción que no es muy importante de la radioactividad natural, y yo diría casi nula en ciertos lugares. Entonces la pregunta que yo me haría sería ¿cuál es la cultura de la radioactividad en el país? ¿Cuáles son las percepciones de estos lugares radioactivos? ¿Cuáles son los saberes que pueden desarrollar la gente sobre el vínculo entre tal lugar y sus problemas de salud? Aunque la palabra radioactividad no sea utilizada, pero pueden tener formas de explicación de eso. También pueden haber formas de actuar, de regular estos problemas, y también claramente mecanismos de ignorancia. Se podría trabajar en fuentes termales, por ejemplo, también en minas, como lo dijimos con Yasser y Raza anteriormente, pero en otros tipos de espacios naturales también. Y lo que me interesa a mí es también saber cómo los saberes de la población se articulan o se oponen a los saberes científicos que están inscritos en la reglamentación y en los estándares que recién se publicaron. Bueno, pues ya terminé. Así a lo mejor les voy a comunicar esto, que es el libro que hicimos sobre la Amazonía, que lo pueden cargar en este vínculo que tienen acá, y diferentes papeles que publicamos.
Tal vez el link lo podrías poner en el chat, por favor.
Sí, ahora mismo. Ahí va. Bueno, pues lo siento por las diapositivas, que me quedé un poco ahí tonta de hablar así nomás.